Okay, I'm going to switch to English. So again, if there are any kind of vocabulary questions, just raise your hand immediately, and I'll try to answer them as soon as possible. Okay. Also my pronunciation, if anyone doesn't understand that, just raise your hand, and I can repronounce things. Okay, so today I'm going to be talking about property-based testing. Okay, it's a complicated word and a complicated structure because it has two frightening words in it. The first one's testing, and the second one's property. Because what is a property, and everybody loves testing, of course. So first of all, I'm Thrift. I'm a computer science student here at the university, and I'm also a software engineer here at Newstore. Okay, first of all, I want everybody to actually get up now. Everybody please stand up, yeah? Or I'm going to grab you. Yeah, everybody please just stand up for just a moment. Yeah. Okay, and I want you to do some stretches, okay? Everybody just do some stretches. Come on, I'm standing here as well. Do some stretches, okay? Okay. Yeah, just if it cracks, that's probably good. I also got another one. Yeah. Okay. Okay. That's all. Okay. Everybody can sit down again. It's okay. Just after some pizza, some drinks, just have to get the blood flowing again. Okay. First of all, a couple of prerequisites. This is a more of an advanced technique. You won't see many juniors doing this, and often seniors. It's a more theoretical technique as well, so if you have a very heavy theoretical or mathematical or functional background, then you might know this, but for most people coming down the classic route, they won't know this, and it'll seem a little bit foreign. It requires a little bit of theory, okay? I'll try to keep it to an absolute minimum, but it does require a little bit of theoretical background, and it requires a lot of practice. We're going to focus on pure functions here, just because it's way easier. What is property-based testing? So, whenever you ask, okay, what is X? The first thing you do is you put it into Google, okay? And straight away, you'll see right at the top, it says scholarly articles for property-based testing. So you immediately know, okay, maybe not the quick win that I'd hoped for. And right down at the bottom, you'll find this, at least for me, what's down the bottom, is QuickCheck. So what's QuickCheck? Whenever you Google this will come up immediately and all the time. Which is kind of a problem because if you look at the definition, it says QuickCheck is a combinatory library originally written in Haskell. Okay, so first of all, you don't need to know what a combinatory library is, and you don't even need to know what Haskell is for this talk, okay? But you need to understand it's assistant software testing, and then you can read this word, generating test cases. So we're not actually going to do code generation, but we are going to have a tool help us create and generate test input. So, what do we usually do? Okay, all of us obviously write unit tests, and what we usually do when we write unit tests is we do example-based testing. Okay, what do I mean by that? If we look at this example, we expect the distance function between the planet Earth and the planet Vulcan to be roughly 1.5 times 10 to the 14th power kilometers, which is roughly 16 light years. Yeah, we all know and love this, okay? Not just Star Trek, I mean testing. So, that was example-based testing. So, what is a property? Okay, the question was raised here earlier on as well. A property is described by Scala test as a high-level specification of behavior that should hold for a range of data points. So let's break this down. High level, what does that mean? Just now, our example was very specific. We wanted the distance exactly between Earth and Vulcan, and that's 16 light years, and that was it. That's all we described about this function. So that's not very high level. It's very specific. Secondly, the behavior. Again, we didn't describe what the function does or how it behaves. We just said, if these are the inputs, 16 light years is the output. That's it. And range of data points, our range was 1. So, not terribly good. So, let's look at comparison. Okay, up here is our function distance, which takes 2 vectors in 3 dimensions. I'm assuming we all live in 3 dimensions. If anyone lives in a higher dimension, please let me know, and I will adapt the slides. So, we have 3 dimensions, 2 vectors, and it returns a float. The float is then the distance. So, Our example, Earth to Vulcan, is 16 light years. Okay, we know that. Earth to Alpha Centauri, which is, I believe, the closest star to our solar system, is 4.37 light years. So those are two examples. Okay, I think we can get that. If we write tests like this, I think we can all understand that. So what's a property? So first of all, can you read that? Yeah? Okay. Okay, this is A and B are three-dimensional vectors. Okay, this is the set of real numbers, and to the third power means we have 3 dimensions, so it's a vector. Okay, so we have 2 vectors. We don't know what these vectors are. There could be anything inside of r to the power of 3. So, unfortunately, MathJax doesn't like to render big sometimes, so I hope you can read that. So our distance function between A and B always has to be greater to or equal 0. Okay? No matter what A and B are, it always has to hold true. Okay? And the distance between A and A, so the same point, is always 0. And I think we can all see that. If I go from Earth to Earth, I think my distance is going to be 0. Okay, so, and the distance between A and B, if A and B are not the same, always has to be greater than 0. There are no negative distances. Of course, there are negative vectors, there's negative velocity, but there are no negative distances, really. At least not in classical mechanics. And the distance between A and B is always the same as the distance between B and A. So if I go from Vulcan to Earth, it's the same distance as going from Earth to Vulcan. Simplified, obviously, you know, rotations, but simplified. Let's lose the solar systems. Okay, so now we have loads of tests that we could generate with this, because there are so many numbers and variations in the set that we just described, yeah, in this r to the power of 3. So you might be thinking to yourself, okay, this is great, yeah, for mathematical functions. I don't write numerical computation. And if you do write numerical computation in JavaScript, please stop. Don't do that. But I can see that obviously many of you, or many of us, me included, we don't do numerical computation. Okay, so you might be thinking to yourself, how does this really benefit me? So this is a quote by Jessica Kerr. Writing tests first forces you to think about the problem you're solving. Okay, that's TDD basically, yeah. Writing property-based tests forces you to think way harder. Okay, so nobody actually wants to think hard. An article I read started with this quote, and I thought that was a bit unfortunate, because right at the top it discourages you. It says it's way harder. And this is something that you will see often, someone coming from a more traditional background. They'll think it's way harder, but it's not. It's not any harder than normal testing. Sometimes it can be really difficult to come up with good examples. I litter my tests with pop culture references to make them funny, but I mean, sometimes it's a bit difficult to come up with examples. So I don't think it's harder to write property-based tests. It's just different. You just have to look at it from a different angle. So if you're still not convinced, and you say, well, adding 1 and 2 is not the same as writing a user interface, very crude user interface, might I add, well, maybe recently you've heard of this library, okay? Like a couple of here have been talking about it. That is a way to describe, you know, user interaction more functionally. You might have heard of it already. It's called Redux. So little known library. Yeah. So you don't need to know Redux to understand this, but I'm going to use Redux as a good example because it uses pure functions. Okay. So what we often have in Redux is a reducer. Okay, this is a PostReducer. Think about this like Twitter, like a super simple Twitter client maybe. You have a bunch of posts, and then you can add a new post, and you can delete a post. So if we add a post, we simply add the payload to the already existing array of posts. And if we delete, we just filter for the ID, and then that way remove the post. Okay, and this is our action creator. Yeah, also, you don't need to know, if you know Redux, this will be familiar. If you don't, just see it as a pure function, doesn't matter. So, basically what this does is it returns an object with 2 fields, type and payload. The type is the add post, that's what we switch on here, and the payload is the post that we pass it. This is the type for the post. It has 3 fields, an ID, which is a number, a content field, which is a string, and whether it's a draft or not, which is a Boolean. Okay, so we have 3 different fields, 3 different data types. And this is our action creator. It's fairly straightforward. So now if we test this action creator, I know it's not a terribly interesting test, but this is our test for our action creator. Fairly straightforward. We expect that if we call the action creator with this object, that it will return to us a type of navigate to, and the payload should be the same as we passed in. Nothing special here. So this is a super simple property-based test. Okay, so what do we have here with one example? So our range is 1. Yeah.
There's one mistake there in draft.
Oh yeah, okay. Yeah. There should be a T there, yes.
But the test is correct.
But the test is correct. The test is correct, yes.
But flow says.
But flow wouldn't agree, yes. Okay, so this gives you 100% 9 branch and statement coverage. Cool. You're done. Right? Well, yes, if you only aim for this, but that's the coverage. It doesn't actually tell us much about what we actually tested, because we didn't really test much here. Almost just the same code. So let's look at this type again, okay? ID is a number, content is a string, and draft, now with a T, is a Boolean. Okay, let's break this down. Going a tiny bit into type theory and bringing it back into set theory as well. Let's look at Boolean as a set. Okay, Boolean as a set has 2 possible options, true or false. I think we can all agree on that, at least until quantum computers are a thing. Okay, so the cardinality of Boolean is 2. Okay, because there's 2 values, true and false, and the cardinality is simplified. You can say it's just the amount of elements. Number is roughly equal to the real numbers, very roughly, because obviously it's limited to how many bits of computation we have, but for us, this will be roughly the same. So the cardinality is roughly the same as well, which we know, of course, for the real numbers is infinite. There is no limit. And again, string as well, there's an unlimited combination of strings, really, again, only really limited by our computational power. But for our intents and purposes, infinity is enough. Okay, so if we now look, what is a post, okay? Or what are posts? This is the post set. This is a Cartesian product. So basically, this gives us a 3 tuple. So now we have the numbers combined with the strings combined with a Boolean. So we have 2 combined with infinity, combined with infinity. So that basically gives us 2 times infinity possibilities. So try covering those with example-based tests. You won't. Okay, so this is just a brief example. You can see it like this. It's a 3 tuple, basically. 1, hello, and true is an element of this post set. Okay, we're going to see this post set again a little bit later on. So how can we rewrite this using property-based testing? I'm using a library called JamesVerify. Whenever you see JSC, it's JamesVerify. There are a number of other libraries available, but I'll get to that later. So, what we say here is we're defining a property, and we're saying, okay, for all, whatever is this, the following needs to hold true. So for everything in here, this function needs to hold true. That's this for all. So we define a record, which is basically just an object with 3 fields, as I showed earlier for the post, an ID, content, and draft. And the ID is a natural number. I know just now I said real numbers because in theory that's more accurate, but obviously for IDs we would usually use natural numbers. The content is some kind of non-empty string. Also, non-empty string in JamesVerify means it could be anything. It could be all sorts of crazy UTF-8 combinations. So this will really test your functions. And draft is a Boolean, so that will give you either true or false. The point is, we don't know what these are. We said what their behavior is. Yeah, this is a natural number, this is a string, this is a Boolean, but we didn't say test or true or 1. We don't know. We just said what it should be. So, JamesVerify will generate a bunch of inputs for us, randomly, every time. a different set every time, randomly, as many as you like. I think the default is 100, but I mean, with modern computation, you could easily go way, way higher, do several thousand if your method is not super complicated. So, whatever JamesVerify creates here is this. This is our test function. So, we expect the action type to always be add post. I think that's pretty straightforward. And then the rest is not terribly interesting, but it shows the concept. So action payload content should always be the same as the post content, no matter what. The ID should always be the same, no matter what. And the payload, the draft should always be the same, no matter what. Now, you might think, it's trivial, I can see that, but the computer can't see that. And somebody reviewing your code might not be able to see that. But this way, you can prove it in a way, or you can get closer to a proof. Because you can say this holds true for all of these. I mean, it's a trivial example, but your action creator might do a little bit more, maybe some kind of filtering, and JamesVerify will really test your functions. Like, I've banged my head against the wall about the edge cases, so it'll definitely improve your code quality. So let's look again at the reducer. Now we're going to test the reducer the same way, using JamesVerify. Again, we create a record, so this is just the post again. I just call it payload here for short. And I also inline the action here, so I could call obviously the add action creator here, but for the simplicity, I just inlined it here, add post, and the payload, yeah, which will be added. And we define a previous state. We could also have JamesVerify create a previous state, but for simplicity's sake, this is always going to be an empty array. So if we call this reducer with the previous state, which is just the empty array, with this kind of payload, well, what do we expect? Well, I would argue that the length afterwards should be the same as the length plus 1. We added one element. Yeah, again, it sounds trivial, but this will hold true for any kind of input. So again, we describe the behavior, not the input. We don't care about the input. We don't even actually care about the output, which will be this. We only care about the properties of the input and output. The property is a length. This length, for example, so that's what we care about. And the input properties are natural numbers, non-empty strings, and booleans. So that's what the properties are in this case. And also we expect to find the post inside of this array as well. Like if this didn't hold true, then somewhere we created an element, but it's not the same as our payload. So I think that should raise some flags as well. So to prove to you that you can break down many things into a more mathematical way, I'm going to try and describe very crudely, okay, any mathematician in the room and watching later on probably rip my head off at this, but I just want to give a basic overview how you could describe this using mathematics. Yes?
Makes it sense every time test empty state?
Well, that depends. As I said, you can have it also generated by JSC if you like. But if you want it to be constant, you could have it like that. That really depends on what you want to do. Ideally, yes, this should be random as well. Okay, so again, I think this is a little small. I can. There you go. Okay, I think that's a bit better. Math jacks again. So we define a P, which is some kind of element in this post set that we defined earlier on. So this is, again, a 3 tuple. And then a capital P is an array of 0 or more of these posts. Okay, that's this little star means 0 or more. Okay. And now we execute the PostReducer. Now, I've simplified here instead of like nesting it in the state, and I just assumed like this is our only state. And instead of having the action creator here, I'm only passing in what is the payload. So we're reducing reducer to just this add post function. So p marked is now basically what is next state up here. And the cardinality of the old set +1 should be the same as the cardinality or number of elements as the new set p marked. Yeah, that's the same as this line. And again, we expect that p wasn't in the original set, so that's this. And now we expect that p is in p marked. Okay, so this is something that comes up all the time, this kind of function. You add something to the state, and maybe modify something inside the state, and you can show it in a mathematical way. So if you think that you can't transform your complicated user input into, well, properties, then you just have to think about it differently. Think about what is my function actually doing. Okay, so one more example that you will see often is filters. Okay, I have my filter. What the filter does actually is not important, but it has interesting properties. So we generate two inputs here, two arrays of natural numbers. Okay, I've called them A and B. You could call them array A and array B, or array 1 and array 2, doesn't matter. But I just call them A and B because I'm lazy. So these are two arrays, so we can concatenate them. So if I filter and then concatenate with a filtered array of B, that should be the same as filtering an already concatenated list of A and B. Yeah? If there's any question or this doesn't make sense, then ask. Sometimes it takes a little bit of time to wrap your head around it. So I'm going to leave this slide up for a little bit longer while I talk more about it. Also, we expect that no matter how often I apply the filter, it shouldn't change the result. You can also, by the way, JamesVerify can automate this as well. You can tell it, try this a random number of times to really make sure this holds true. But here, for simplicity, I just did that myself and lined it. So no matter how often I filter the array and then filter the array again, the result should not change because the filter hasn't changed. Okay, I'm going to do that a little bit longer just for everyone to understand. And for those who've already understood it, there's a third property that could be tested here. That always has to hold true. So if anyone has an idea what that third property could be, I mean there's many more I'm sure, but just one more property. And don't rush, I have time, just think about it.
Filter with array should not be the array.
You can't always say that because you don't know. It could filter for anything greater than 2. Yeah. But it's close to that.
Filter has a return type of A and B, A or B. The type of?
Yeah, the type is the same. The type is the same, yes. But Flow or TypeScript should check that. We could check that as well. Yeah, that is a point. We could also check that it always at least returns an empty array, for example. It should not return null. It should always at least return an empty array. We could test that. Or another one we could test is the length of a filtered array can never exceed the length of the input. We can't create new elements in a filter. So we could add my filter a dot length has to be at least a dot length. At most a dot length. So
not every time.
No, at least. At least, yeah, it has to be smaller or equal to. Yeah. So that would be a third property that you could test here as well. Yeah. But you can also test it the other way around. Like you could also have negative tests. Yeah, that would also work. Like you don't always have to do it in a positive way like I did. That this should hold true. You could also say this should never hold true. That also works. That might be easier sometimes. Okay, some quick notes. We'll focus on pure functions first of all. If you do this, focus on pure functions. Okay, you can do side effects, but it'll be a pain. Try to break down your functions as well. Like really, like I did here with my filter. I broke it down into the very basic components. Think about this. What does my function actually do? Because if you think about it this way, like with the filter just now, what does it actually do? I don't care about if I put in, well, x and y, and then I only get x back. I don't care about that, or I don't actually care about the distance between Earth and Vulcan, but I care that it gives me a sensible result. So what does my function actually do? Okay, in the end, all our programs are data transformations. Okay, no matter what you do, you put in some data and you get out some data. And obviously, there are ways to, well, that make it easier to express that, like for example, Redux, and in a way, React as well. By the way, you can use property-based testing for React as well. But that's a little bit more complicated. So, but in the end, all our programs are data transformations, no matter how complicated. Think in terms of the properties of the input and output. I said that earlier on as well. What is our input and what are the properties of our output? Not implementation details. Like with the filter, anything could be that filter. I don't care. But also, if I review it, or if I look at it later on, I don't have to care because I can just look at the properties and I know what it will do. And sometimes you think, well, this is just a one-liner, this is fairly simple. While writing our router, by the way, our router makes extensive use of property-based testing. While writing our router, we had a filter that filtered out old routes that were no longer needed in the stack and that could be removed from the DOM or the view hierarchy in general. And while it seemed quite simple on the surface, and even looking at the code, you might think, well, this is fairly straightforward. There was quite a lot of nuance to the code, and describing it in terms of properties made it clearer what we actually tried to do. And we didn't focus on the implementation detail because anyone who's ever written a router will know that those are often horrid. It will catch more errors and edge cases. I said that earlier on as well. Sometimes you bang your head against the wall because you just can't get the test to pass, but often it's because you actually made a mistake. Like your assumptions are incorrect, or there's a bug. JamesVerify has certain heuristics in it, as I said. It won't just try random strings, but it'll actually try random strings of really awkward strings. So weird UTF-8 characters, or if there are ever numbers involved, you can be 100% certain it will try 0. If you say it could be any number, then also try a negative number. Yes?
How does it display the errors? So
yeah, the errors.
What were the inputs for the errors?
Yes, the errors will show you, these were my inputs, this was my output, this is not correct. Yes. Yeah. It will take practice. Okay, this took me a long time as well to, and I still have issues. I would never say I've mastered this technique, never. But I think it's fun once you get it done, because the things, once they work, you can have confidence that they will continue to work when you change them, and confidence that it won't break. And that's not broken in the first place as well. Okay, where to go next? As I said, JamesVerify, that's one of them. There are so many others. And JamesVerify has a bit of an awkward syntax, but I found this is the most actively maintained. There are some others that have really nice syntax and very nice API that haven't been touched since 2014 or early 2016. If I had the time, I'd pick those up and edit them, bring them up to speed. Unfortunately, I don't, so if anyone wants to do that, that's certainly a place where you can contribute. But JamesVerify at the moment seems to be the go-to. So read the documentation and read it thoroughly several times. It's quite complicated. They use a lot of overly complicated words, and you can really see it's like a functional background. So if you have any questions, open up an issue, tweet them, or tweet me, or Slack me, and I'll see if I can help. first of all, try and augment your example-based test. Don't throw your test suite out the window, but the next time you're writing a test, maybe think about, okay, could I use a property-based test here or not? And that's it. This is a brief introduction to property-based testing. I hope I could excite some of you for this. I find it very exciting. I think it's really fun to do it. It's very rewarding, certainly. So thank you for your attention. And any questions, either now, later on, or whenever. But thank you. Okay, questions?
Short question about the runtime.
Yeah.
You write this test, and as I got the thing right, it will try it with a random value. It will try it again with a new value.
Mm-hmm.
And if I write such a test, it will run 100 times, 1,000 times, forever.
Yeah.
And if I have several of these tests, don't know, there's does it stop sometimes, or how do you do this? How often do you run the test?
Well, whenever I write code, I always have the test suite running.
Yes.
But of course, I only run the ones that I don't have the entire test suite running. Only the ones that change. I haven't noticed any kind of really speed. Like my default is to go between 100 and 200 tests. But that's because if it were a particularly hot path in my code, maybe I do more. There might actually be some cases in the router which is like a particular hot path where I chose to do even more tests, but I haven't really noticed any kind of major slowdowns.
You run such tests in continuous integration?
Yes, yes. But they also run in parallel, so I hope. Yeah.
So are these tests also consistent every time?
You can opt into consistency. You can give it a seed for the random number generator, or you can have it random anytime. So you're free. Our tests are constant, always the same. But I change it every time I change the function. I change the seed.
Okay, so why is property-based testing isn't that popular in JavaScript in general?
In general, yeah, because it's for the same reason Haskell isn't terribly popular. Haskell it comes from a more theoretical, more academic background, and academia has a great reputation of bad communication. So that's really it. It's just the lack of communication outwards, and of course the lack of theoretical, background.
I mean, you could clearly see that the abstraction is, was clear to see that you don't have to do anything else other than just throwing in the needed properties. And that's it.
Yeah.
So I think that's much simpler than writing the code or the test itself with thinking about the properties.
You mean about the input values, the properties of the object, not the properties.
Yeah.
Okay. Yeah, in a way it is, but it does force you to think differently about it. Yeah, you're not thinking, because often, of course, especially if we develop things like stories, on our story card it says, like our persona, yeah? Tim opens the shopping bag and inputs 1. So, I mean, that's a prime example for example-based tests, so we see that everywhere, and we're very familiar with it. That's the only reason why we do it that way, and this is not more popular. Also, it requires languages that really do have an emphasis on functional aspects. There is actually a library for Java, JUnit check, I think, so it must be possible somehow, but it's certainly much easier to do in functional languages. So I know that Clojure uses that as well. Clojure, it's called generative testing, and obviously Haskell does it. Scala, there's a big community around that as well, but I mean, Scala is a lot more functional as well, and a lot more used in academia as well.
Is this compatible with TDD?
Yeah, I had that point on there before as well, as a negative. I like doing TDD, and I still find myself using example-based tests first for TDD, because sometimes it's easier to think about it. But that's actually a trap, because then you're in this example-based world, and then you're thinking about, okay, how do I get this test green with this example? Yeah, but that doesn't actually tell you if the function actually behaves the way it should. So I try and force myself to use more property-based tests when doing TDD, but I definitely find it a little bit harder.
Sag vielleicht kein Jest, das bei
we use it with Jest. We use it with Jest.
Aber dass das von Haus aus so funktioniert. Also ich finde die Syntax extrem hässlich mit diesem Neck-String und E-String.
Ja, die Syntax ist nicht so gut.
Ich kann nur von einem Mathematiker.
Komm, fühlt sich auf jeden Fall so an, als würde es aus der Richtung kommen. Also tut's auch. Also das merkt man halt auch an der Doku.
Das ist so ein Ansatz, was für Function Programming da ist, ne?
Absolut. Also in der Function Programming Welt bist du damit absolut zu Hause.
Das heißt, die OOP und maximal, was man damit testen kann, wahrscheinlich irgendwie quasi Lambdas oder sowas.
Wo damit testen kannst?
Nein, in objektorientierten Sprachen gibt es ja.
Ja,
so,
wie gesagt, ich habe ja auch gesagt, pure Funktionen, und sobald du halt irgendwie Internal State Management hast, State Changes hast, es geht auf jeden Fall, aber es ist nicht ganz, fühlt sich, glaube ich, nicht ganz so natürlich an wie in der funktionalen Welt. Gerade mit dem ganzen Immutable-Kram und so. Ja. Okay. Okay, if there's no more questions, then I thank you again for your attention. If there are any more questions, ask